Alright, this is Mr. Gillen, and today we're going to be looking at Lesson 14, Day 6. This is actually your independent practice answer key. So if you haven't tried your independent practice for yourself yet, I want you to do that first, and then watch the answer key and correct anything that you may have made mistakes on for your quiz tomorrow. Number 1 says, which statement is true about the distance from the food court to the store? So let's look at the food court and the store, and lucky for us that they are exactly horizontally aligned. So there's several ways that we could go about finding the distance between them. The first way we could find the distance is just by counting. 1, 2, 3, 4, 5, 6. They're 6 units apart. So I know that there's 6. This distance is 6. Okay, I know that on your quiz there's going to be some questions about how you can use the absolute value to figure out how far apart they are. And so when we're determining the distance between 2 points, we want to use a reference point, and in this case it's the axis, the y-axis, the vertical axis here. Okay, and on the y-axis, these both have the same y-coordinates. This coordinate would be -5, -3, and this coordinate would be 1, -3. Our reference point is the y-axis, so I know whatever the distance is. When I say distance, that indicates absolute value. The distance of 1 from the y-axis and the distance of -5 from the y-axis. The sum of those two things will represent the entire distance altogether. So the sum of the absolute value of -5 plus the sum of the absolute value of 1, or the distance of the food court plus the distance of the store from the y-axis, should equal the total distance. 5 plus 1, which equals 6. So we have some choices here about which one is true. So the distance is equal to 4 units. That's obviously not true because we know the distance is 6 units. It equals the distance from the movie theater to the arcade. Okay, so let's look at the movie theater to the arcade. We found the distance between the food court and the store. 1, 2, 3, 4, 5. Looks to me like the distance between the movie theater and the arcade is a distance of 5. And so that's definitely not true. It is less than the distance from the movie theater to the arcade. That's not true. It's actually longer than the distance from the movie theater to the arcade by 1 unit. So because ours is actually 6 units and 5 is less than 6. Or it is greater than the distance from the movie theater to the arcade. So yes, that one makes sense. 6 is greater than 5, so D would be the correct choice. A new coffee shop is being built. Its location is the reflection of the arcade's coordinates across the y-axis. Which procedure will find the correct distance between the arcade and the new coffee shop? Circle all that apply. So when I'm reflecting across the x-axis, I'm going to talk about what happens then, and then when we reflect across the y-axis. Talk about what happens then. Any point reflected across the x-axis, x-coordinate stays the same. Y-coordinate opposite. So we would have x, comma, the opposite of y. When we're reflecting across the y-axis, the very opposite happens. We would have x-coordinate is the opposite, and the y-coordinate stays the same. Alright, and I could represent that as the opposite of the x-coordinate, and then the y-coordinate stays the same. And so that's important to keep in mind, because whatever we're reflecting across, that is the actual coordinate that stays the same. The other coordinate is the opposite. So again, it says which procedure will find the correct distance between the arcade and the new coffee shop. So if a new coffee shop is being built and its location is the reflection of the arcade's coordinates across the y-axis, we need to figure out where the new coffee shop will be. So I think we need to actually reference our last picture here. We need to find the arcade, so I'm going to erase some of this here for this problem. So the arcade is here. And we know that the new coffee shop will be exactly on the other side of the y-axis from the arcade. So this is the y-axis. And I know that the arcade, 2, 3, 4, 5, is 5 away from the y-axis. So the reflection point would be exactly 5 more away from the y-axis on the other side. So this would be the coffee shop, CS. Okay, so that's one way we could do it. We could find the distance or the absolute value of 5 from the y-axis. This distance is represented by the absolute value of 5. And there's an opposite value of 5 that would also have the same distance from 0. That would be the opposite, the absolute value of negative 5. So if the arcade is at 5, 4, the coffee shop would be at negative 5, 4. And again, because we're reflecting across the y-axis, the y values stay the same. The x values are the opposite. So let's go back to our choices here. It says find the sum of the absolute value of 3 and 3. Okay, I'm not really sure. I'm guessing that that would be, I'm not really sure how they thought that. Oh, these are really 3, not 4. Sorry about that. I'm assuming that they probably got their x coordinates and their y coordinates mixed up when they did that. So yeah, that wouldn't be a good choice because we actually want to know, we want to use the absolute value of 5 and negative 5, not 3 and negative 3. Well, it'd actually be 3 and 3. So that's not a good choice because that's how far they are from the x-axis. We could simplify the expression, the absolute value of negative 5 plus the absolute value of 5. That is one thing that could happen because we could find the distance between them. That's what we're actually trying to find, is the correct distance between them. Once we know where the opposite is, we know that this represents the absolute value of negative 5, this represents the absolute value of 5, this distance here and this distance here. So yes, the total of those two distances would be the distance between them. So choice B is a good choice. Find the distance between 5, 3 and 5, negative 3. Okay, 5, negative 3 is actually down here. So that would be fine if we were talking about our reflection across the x-axis, but because this is x and not y, that's a bad choice. We were looking for the reflection across the y-axis. And then finally, find the distance of each point from the y-axis and then add. So yeah, we could do that. That's the first thing that I did. I counted 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's 10. That would be counting. So there's a distance of 10 between them. Number 3 says, each letter point represents a location on the number line. Choose true or false for each statement. Part A says B is at the location of negative 3 and 1/2. This is something that's commonly misunderstood because a lot of students think, oh, okay, well, here's negative 3 and then a half more than that. That would be there at B. Unfortunately, though, negative 3 and 1/2 would be somewhere between negative 3 and negative 4. This would actually be the correct coordinate for negative 3 and 1/2. That's 3 and 1/2 units from 0. So 3 units and then another half unit would be this far. Not at B. That would only be 2 and 1/2 units from 0. So that would be incorrect. That's false. C is a positive number. Well, if the positive numbers are to the right and the negative numbers are to the left, 0 is actually greater than C. So if it's greater than 0 is greater than a number, then that number must be negative. You can see it's to the left of 0, and that's one of the things I need you to explain to me. In the last quiz, we had a hard time with that. Remember, when I asked about how you know things, really, you just need to tell me because it was to the right or because it was to the left. I knew it was greater because it was to the right. I knew it was smaller because it was to the left. C is to the left of 0, it therefore must be negative. So C cannot be positive, so that would be false. B and D are opposites. Well, if they're opposites, they must have the same distance from 0 as one another. D is 2 units from 0. B is actually 2 and 1/2 units from 0, so that can't be true. B is actually farther from 0 than D, so they are not opposites. False. The distance between A and B is negative. Well, before we go anything, we don't have to look where A and B are at. We know that there's no way distance can be negative. There's always space in between two places unless it's the same place. So as soon as you see distance negative in the same sentence and somebody's trying to claim that the distance is negative, you know that's false. And so part E, our one lonely true answer this time, says the absolute value of A is greater than the absolute value of F. That can be tricky. On this number line in particular, they do have number values with each of the letters. Some of our number lines don't. But because we do have numbers with these letters, we can go ahead and consider the numbers themselves. A is 5. Sorry, at the point -5, its distance from 0 could be represented by the absolute value of -5. The letter F is at 4. Its distance from 0 could be represented by the absolute value of 4. I know that the absolute value, or the distance of -5 from 0 is 5, and the distance of 4 from 0 is 4. So A, in this case, must be greater than F over here. So that is true. 3 points representing the corners of a rectangular garden are -7, 3, 7, 3, and 7, -3. So it looks to me like they're giving us points A, B, and C, and they're telling us that this is a rectangular garden. So a few things to know about rectangles are it has 4 right angles. So if I put a point here and I connected these like so, this would not be a rectangle, obviously. Must have 4 right angles and 4 sides. And so initially what we would have is we'd have to plot point A, B, and C. What we'd have to figure out is where point D is at. And so we could do that several different ways. This is graph the points representing the corners of the garden and explain how to find the coordinates of the fourth corner D. Then graph and label that point. So one way that we could find where D is because it's a rectangle and because C and B are opposites. You can see that they are both 3 away from the x-axis. So they're at the point 7, -3, and 7, 3. I know that A must also have a reflection on the other side, so I can either do one of two things. I can either reflect A over the x-axis, or I can reflect C over the y-axis. So either way I want to do that is fine, but I know there must be a point in quadrant 3 somewhere that is reflected from B or C. Sorry, C or A. So it looks like the book says the distance from B to C is 6, so D is 6 below A. So yeah, it looks like they found the distance here and said, okay, if that's 6, then this distance must be 6. So D must be located at the point -7, -3. That's just another thing we know about rectangles is the opposite sides must be congruent or equal. There are 2 pairs of opposite sides and they must be equal. So D was down there in the third quadrant at the coordinate -7, -3. Finally, it says name 2 points that are reflections of each other across the x-axis. So if this is the x-axis and I folded along the x-axis, I want to know points that would land on top of each other. So you could say point A and point D are opposites of one another and reflect across the x-axis, or you could say B and C. Those would both be correct answers. Across the x-axis, A and B would not be good. But if we were talking about the y-axis, like in this next question, and I was talking about, let's make that one blue, folding over the y-axis, the points of reflection would be B and A. If I folded on the blue line, B would land on top of A, or C would land on top of D. So those are the pairs of reflective points across the y-axis. Finally, it says to find the distance between 2 points that have the same y-coordinate. So let's look at the points. It looks like I had the point 7, 3. I had the point 7, -3. I had the point -7, 3. I had the point -7, -3. And so I'm looking for 2 points that have the same y-coordinate for this one. It says 2 points that have the same y-coordinate. So -3 and -3 match, so I could find the distance between D and C. Or 3 and 3 match, so I could find the distance between A and B. You'll see that either way we'll have the same distance in between. Again, just to re-emphasize how an absolute value works, if this is the coordinate, I want to know how far it is from that y-axis. That's how far left and right I've gone, so that's the x value. So this distance from here to here, represented by the absolute value of -7. Remember, the absolute value bars mean how far is it or what is the distance. And then here we have the absolute value is 7. We know that it's 7 away, obviously, and that's why this strategy is beneficial. So 7 plus 7 equals 14, and we would do the similar thing with the A and B values. So that's it.